stellar death and planetary birth, the beginning of time and the end of the universe. As it enters its 15th year in orbit, NASA's Hubble Space Telescope continues to be the most productive space science mission in history, showing us the wonders of the cosmos like no other telescope ever has. Stars die in one of two ways. They slip gently into the night, or they go out in terrific blasts. When stars die quietly, they often create majestic sculptures of gas and dust to mark their graves. For centuries, astronomers studied these nebulae, thinking them to be simple bubbles of gas. But Hubble observations have revealed structures of surprising complexity. One such nebula is the helix.
What we expected was something much like my glasses here, where we'd have a rim, and then we'd have a disc of material like the glass lens I have. And then what was interesting to us was that the glass would be tipped with respect to the rim. So in the Helix Nebula, the disk is tipped with respect to this ring.
The complex double ring structure of the helix is baffling, inspiring new questions about how stars die. For more than a year, Hubble has been observing a peculiar star in an obscure constellation. That star flared up once and became briefly the brightest star in the Milky Way galaxy. Hubble sees the star's light echoing off of gas and dust clouds lurking in the space surrounding it. On October 9, 1604, something flared up in the western sky. Astronomer Johannes Kepler observed the event, which he called a nova, or new star. The telescope had not yet been invented, so sky watchers could only observe the exploding star with their naked eyes. Modern astronomers have an array of powerful space-based telescopes, including the Spitzer Space Telescope, the Chandra X-ray Observatory, and Hubble to watch the heavens. These great observatories are surveying what's left of Kepler's supernova in infrared, X-ray light, and visible light.
Objects like supernova remnants are, by their nature, multi-wavelength objects. They emit over radio waves all the way to X-rays, all different kinds of light. So to really understand them, we have to look at them with different tools, different telescopes that allow us to see that different kind of light and understand different components of the object. So for instance, Spitzer sees the heated dust. The Chandra telescope really sees the hottest component of the gas, pretty low density gas, but very hot gas. And Hubble sees the denser component of the interaction of the blast wave with the surrounding interstellar medium.
Stellar explosions are incredibly destructive, but they also seed the universe with elements like carbon and iron that eventually form planets and even people like ourselves. Hubble and its sister telescopes show us how stars die and give us clues about their beginnings. Stars form in great clouds of gas and dust, and planets form from the leftover material surrounding them. But just how that mechanism works is still a mystery. Spitzer examined stars about the same age as our Sun, for the first time finding dusty disks around stars known to have planets. Hubble watched much younger stars, finding solar systems in the early stages of development. Together, the Hubble and Spitzer observations are snapshots of solar systems at different phases of their evolution. From these findings, we are learning more about how our own solar system came into being. From distant solar systems to our own, Hubble continues to lead the way in space exploration. On the extreme fringe of our solar system, farther than anything we've seen before, is a small body of ice and rock called Sedna. Sedna's discovery turned up a mystery. Because of its slow rotation, astronomers expected Sedna to have a moon, but it doesn't, so the mystery remains. Jupiter and its complex system of moons have fascinated astronomers since Galileo. In 2004, Hubble caught a rare Jovian family portrait as three of Jupiter's largest moons, Io, Ganymede, and Callisto, marched across the planet's face together. Beyond our solar system, Hubble is watching a cosmic crime in progress. A spiral galaxy that once resembled our placid Milky Way is being shredded as it plunges headlong through a cluster of other galaxies. What is a galaxy?
This galaxy, C153, is flying through a rich cluster of galaxies at 3,000 miles a second. As it does so, the gas in this galaxy, the fuel for further star formation, is being blown away by a tremendous wind. And that will change the galaxy's further history and transform its structure completely.
That wind is swirling from the other galaxies in the cluster, and by stripping C153's gases, it is picking the galaxy down to its stellar skeleton. Our own galaxy may face a similarly harsh fate.
If the present motions we see in our part of the universe continue, our Milky Way and its surrounding group of galaxies will be falling into the center of the Virgo cluster of galaxies in about 50 billion years. If we go right through the middle, this same fate could be what's in store for our galaxy at that point.
Studying galaxies close to ours and in the depths of space can help us solve an even greater mystery. Where did it all come from, and how long has it been here? How and when did galaxies form? Hubble continues its astounding work on that puzzle with an observation called the Hubble Ultra-Deep Field. The telescope stared at the same patch of sky for 1 million seconds, almost 280 hours, to capture as much dim light from galaxies as far away as possible. In taking this image, Hubble is going all the way to the edge.
Our goal is to get to what I call the edge, that is, to the place where we see just the first stars and galaxies in the early universe. We knew from the Hubble Deep Field that we had gotten partway there. And we knew with the new ACS camera, at the height of its powers, we had a chance of getting out to where that reionization edge was. And so we wanted to do the ultra deep field at a time that was early enough for the camera to be at the height of its powers, but also late enough that we knew it was working very well. And so this year was the time.
The Hubble Ultra Deep Field takes us 95% of the way back to the beginning of time, revealing more than 10,000 galaxies, whose shapes and sizes speak of a baby universe caught up in chaos. The light from these galaxies has been traveling for billions of years before being captured by Hubble. The result is an image that stretches across billions of years of cosmic history, back to a time when the first galaxies began to glow. And out past the edge, darkness. This is as far back as humanity has ever seen into the universe, in infrared and visible light. It will take future telescopes looking only in infrared wavelengths to see beyond Hubble's extraordinary range. Will the universe that began in a Big Bang end in a Big Rip? Hubble astronomers ponder both ends of the cosmological question by observing distant galaxies. By gauging the brightness of supernovas in distant galaxies, we have discovered an energy permeating all space and producing a repulsive force that is driving the universe apart at ever-increasing speed. One of Hubble's largest surveys turned up dozens of supernovas useful for probing the nature of dark energy. Dark energy is speeding up the expansion of the universe, forcing us to rethink fundamental ideas about the nature of the cosmos. Hubble played a key role in discovering dark energy and continues to study it. We are learning that the universe we see isn't all there is. Dark energy and dark matter appear to exert a greater influence on the universe than everything we can see or detect directly. Depending on the strength and properties of dark energy, it could cause the universe to end in a disintegrating rip or even collapse back on itself and wink out of existence billions of years from now. From our own solar system to the discovery of unseen natural forces, NASA's intrepid orbiting observatory, the Hubble Space Telescope, continues to expand humanity's understanding of the cosmos.